everybody, my name is Isaac and today I'm gonna be talking about my reflection video. So in this reflection video I'm just going to be going over everything that we learned in this quarter, but not all the tasks. I'm just gonna go through the big projects. So today, currently it's Sunday, 18th of December 2016. So let's start the video. So for the introduction, Introduction. For the first big project, we were doing something about percentage. So for the first 4 or 5 tasks, we were just talking about percentage and stuff. For the second big project, we were also talking about some more percentage, but in the third and fourth, we were doing something different. So for the first big project, we were doing something about percentage. We did percentage, part of a whole other percentage, comparing percentage, percent increase and decrease. We also did finding out 100% given another percent, a critical look at proportional relationship, constant rate, linear equation in 2 variables, the graph of a linear equation in 2 variables, slope of a non-vertical line, joining two distinct point of graph. And by the way, if the tasks are not exactly in a place, like example, if I put linear equation stuff in big project 2, I'm sorry, because we didn't really have much space between them. We just did them and stuff like that. So for the third big project, we were focusing on linear equation. We were writing equations using symbols, linear and non-linear equation in X, and linear equation in X. And for the last big project, we did exponents, like scientific notation like that. So we did exponential notation, multiplication of numbers in exponential form, and magnitude. Basically, magnitude is like we had some rules like for exponents. So a5 times am times an, it can be a to the power of m plus n. So it's like that. So this is all the questions for the big project. I'm just gonna stay quiet for a bit. I'm not sure. I'm just gonna read them out for you. So, question: Shelly earned 20% more money in tips waitressing this week than last week. This week she earned $72 in tips waitressing. How much money did Shelly earn last week? Actually, to think about it, I'm not gonna read it because I have a limited amount of time of recording this. So I'm just gonna put it on the screen for about 10 seconds, and if you wanna see the questions, you can just pause it. So that's the project. If it's a bit fast, I'm sorry. Now I have to be going because since the reflection is very long, I have to be fast about that part. So for this reflection, we have to list at least 3 skills we learned from all of the projects, and the skill must be related to the standard. The standards are these things. Wait, let me highlight them for you. Are these things. So But one of them, it doesn't really relate, but it is a small part of the standard. I'm just gonna tell you that. And we also have to explain each skill and show how I learned it and provide examples of the application of the skills. So basically, I have to explain the skill and show that I know how to do it. Basically, how I know that I learned it. And I also have to provide real life examples. Example for percentage, I can find discounts and stuff like that. So this one will be the first project. So during the Math Big Project 1, I learned about percentage. While doing this project, I learned 3 different skills: converting percentage to integers, finding parts of the percentage, and finding percentage decrease. So converting percentage to integers is basically just dividing or multiplying a numerator with a decimal, the percentage in decimal form, like 0.5 is 50%, and so on and so forth. And then finding a number. Sometimes it's not easy, but sometimes it might be. For example, what number is 40% of 90? 0.4, which is 40%, times 90 equals 36. So 36 is 40% of 90. But some other questions are pretty tricky. Like Brad put 10 crickets in his pet lizard's cage. After one day, Brad's lizard had eaten 20% of the cricket that he had put in the cage. By the end of the next day, the lizard had eaten 25% of the remaining crickets. How many crickets were left in the cage at the end of the second day? So in day 1, he ate 20%, 0.2, and of the 10 crickets, so 0.2 times 10 equals 2. The cricket ate 2. Not the cricket. The lizard, Brad's lizard, had eaten 2 crickets by the end of day 1. In day 2, the lizard had eaten 25% of the remaining crickets. So we have 8 left. 0.25, 25% times 8 equals 2. So he ate another 2 crickets, which means that there is total 4. Wait, I'm doing it. Okay, never mind. Which means that he ate two crickets. That means that he has eaten total 4 crickets. So on the last day, there were 6 crickets. On the last day, he ate 4 crickets, which is 6 crickets left in the cage. I'm doing this all wrong. Okay, so day 2. Okay, they had eaten. I cut. How many crickets were left in the cage at the end of the second day? Start. So Brad had put 10 crickets into his pet lizard's cage. After one day, Brad's lizard had eaten 20% of the crickets he had put in the cage. By the end of the next day, the lizard had eaten 25% of the remaining crickets. How many crickets were left in the cage at the end of the second day? The equation might be a bit confusing because I did this question before and I just put it in one sentence, one line, so it might be a bit confusing. So in day 1, he eaten 20% of 10%. No, 20% of 10 actually. So 0.2 times 10, 2. But at the end of the next day, day 2, he had eaten 25% of the remaining crickets, which is 8. So he had eaten 2 more crickets. So in total, he ate 4 crickets. So they asked how many crickets were left at the cage at the end of the second day. So 10 in total minus 4 equals 6. So there are 6 crickets left in the cage. Some of those examples those are some examples of the first skill. We can use this skill in real life by making the task of finding the number of percentage easier. For example, we can use this skill to determine the discount of shopping rate and saving. So like example, if some pants were 50% off and they're originally 100 baht, we can find out how much money we saved or how many baht off they are. The second one, finding parts of a percentage. So finding parts of a percentage is very similar to the last one above, but is a little bit different. For this one, we just use the process to find percentage. The last one was to find whole numbers. So for converting percentage to integers, we're finding integers, but this one we're finding percentage. We also just multiply or divide the two numbers, percentage and numerator, and then we will find a percentage. Here is an example. Sorry if I speak a little bit fast. 0.5, 50% times, the small dot is times, 100, which equals 50%. Or 1.2 times 100 is 120%. So we're trying to find things like this. A percentage is a number expressed as a fraction of 100. When we talk about percentage, we imagine that a whole has been divided into 100 equal parts. We can use it in real life by better illustrating the numbers in a percentage to enable the reader or target audience a better understanding. Sorry, a bit of a typo. To better understand the common part of an analysis. For instance, when we are conducting a survey to find out the number of people in a place is what age group. So we're finding like in a village, what is the age group? So 200 of the 400 villagers are retired. They're more than 65 years of age, while the other 100 of the total in the community are still in elementary school, 12 years of age. This can be better explained as 200 divided by 400 equals 50%. So 50% are retired, while 100 out of 400, 25% are children. So we know that 50% of the place, of the town, for example, of the village actually, are retired, but 25% are still children. So about 25% I think are the adults. So the last one for the first big project. Yes, there's a lot. In order to find out percentage decrease, we first work out the decrease between the two numbers we are comparing. Then divide the decrease by the original number and multiply the answer by 100. So basically new minus old divided by old. So example, if 2 was new and 1 was old, right? It will be 2 minus 1 divided by 1, like that, times 100. Sorry. If the answer is a positive number, then this is a percentage decrease. A real-life example would be the cost of fruits in a market. When I was young, cost of fruits? No, cost of phones actually. It's a bit of typo, I have to edit that. When I was young, we used to be able to buy a phone with $20,000. Today, a similar item costs as low as $15,000. Therefore, 20,000, which is old, minus 15,000, which is new, equals 5,000. So 5,000 divided by 20,000 times 100 is 25%, meaning that the phone is 25% cheaper in today's world, and it's better. Just kidding. Actually, it is better. Oops, sorry. So we're going on to project 2. So in the Math Week project 2, I learned another different set of skills. This time we learned about constant rates. Constant rates are rates that can be represented by a singular straight line because it is constant. It is a constant rate. Yeah, constant rate. For doing this, we also need actually different types of skills. The skills that I learned are finding out the average speed, how to find constant rate, and how to graph constant rates. So finding out the average speed is basically like finding out a constant rate, but for speed. So finding out the average speed is a very simple task. To find out the constant speed, we just need to divide the distance by the time, or how fast you are traveling. For example, if I am going to Pattaya and it is 100 miles away and I get there in 2 hours, how fast do I need to travel in order to be there on time? So it is 100 miles divided by 2 hours, distance divided by time, which is 50 miles per hour, average speed. This is important for time management. For example, if Ken is going to the airport to catch a flight, he can use math to calculate the time that he needed to get to the airport for him to be late, and he can also do the speed. It takes him approximately 2 hours to get, if the airport is 20 kilometers away and it takes him approximately 2 hours to get there, he will be able to drive a certain speed so that he will not be late. So 20 divided by 2 is 10. So Ken will have to drive a minimum average speed of 10 kilometers per hour. Today in real life, I also did it because I went to McDonald's. And so I calculated the time that I had to come home, but my calculation was a bit off because I didn't know how far my home was from McDonald's. Yay, McDonald's. So basically we reached there on time, like exactly on time, not a minute off. So constant rate, so the next one, constant rate. Constant rate is a change of number that's consistent and predictable over time. So basically it will be like 20, 40, 60. It will be constant. It can be represented as one line, yeah. Constant rate can be determined by a linear graph. We can find the constant rate, oops, I forgot my E, constant rate by multiplying rate by time. For example, Bill uses 20 baht per day for her dog, buys toys and food for her dog. How much money will Bill use for her dog at the end of the month? So 20 baht times 30 days equals 600 baht for Belle's dog. So basically in about a month, Belle spends about 600 baht on her dog. She loves her dog a lot, I can say. You can use this in real life by finding a rate. For example, savings. If Ken uses 5,000 baht a month at the start of January, so basically he has this new resolution to use 5,000 baht instead of 10,000 baht at the start of January. How many baht will Ken have left at the end of the year? So each month is approximately 30 days and each year has 12 months. So 5,000, which is the rate, and 12 months, which is the time, equals 6,000. 5 times 12 is 5,000 times 12 is 6,000. 60,000. So Ken approximately uses 60,000 baht per year. That's a lot of money. But if you think about it, that is true. We use a lot of money every day. Ranting, sorry. So this time, graphing constant rates. Graphing constant rate is a way to illustrate the constant rate in a pictorial matter. It's like for business stuff, you can graph the constant rate of how much money we're earning if it's constant every month, which I doubt so. To do this, you need to know how to get constant rate. So you need to know the last skill I taught you. The graph shows you the constant rate over time. Damn, I do really have a lot of spelling mistakes. It shows you the rate of something. Yeah. This graph will always be linear as the rate is calculated at average speed. We also need to know about the scale and coordinate planes to draw the graph. So we have to know like about 20, 140, like that. We have to know about the coordinate plane so we don't go negative and stuff. So draw the graph. For example, if I am the mayor of a town, which is named The Town, and I am doing town planning, I need to graph the population versus the households of the town. We need to know if we need to build a new house or not. Ignoring birth rate, we will find the settling or migration rate into the town, which is the constant rate. If 30 people move into the town every year, and each house can hold 5 people, how many new houses do we need every year? 30 rate divided by 5, which is the constant rate. Oh no, it's not the constant rate, it's how many people each house can hold, which is 6. So 30 divided by 5 is 6, so we need 6 extra houses every year. So I graphed this on Desmos. Go check the website out, it's cool. So I graphed this on Desmos and I got a linear equation. So yeah, graphing constant rates always has to be linear. So look, so if 30 people move in a town, we need 6 houses. But then 60 people move in a town, 12 houses, 90, so on and so forth. So this one is the third big project. Analyze and solve linear equations and pair simultaneous linear equations. I had a bit of problem with this one, but now I understand more. Oops, sorry. For the third big project, I learned another different set of skills. I learned how to break complicated problems into smaller problems, and how to find linear or nonlinear in X, and finding equivalent expressions. So this is a long one, but I'm not going to explain all of it. To break complicated expressions into smaller problems, we first have to know about constants and variables. Variables are numbers that can vary or change. So doing this, we have to break things down from complicated word problems. So I am going to use an example from one of my tasks. The sum of 3 consecutive integers is 1,623. We have to find the numbers x plus what equals 1,623. Since we know it's 3 consecutive integers. So I'm going to use the variable x to help us in this problem. We have to find x plus what equals 1,623. We know that the numbers are 3 consecutive integers, so we can do like this. X minus 1 plus x plus 1. So it's consecutive, which equals 1,623. First, we have to find out x. We can divide 1,623 by 3. 1,623 divided by 3 equals 541. And 541 plus 1 is 542. 541 minus 1 is 540. So 540 plus 541 plus 542 are 3 consecutive integers, and they actually equal 1623. So we found what x is. So this is a more complicated version, but I'm not gonna go through it now since I have a limited amount of time. So now to the real life one. So we can use this in real life for finding out different things. For example, saving in the family, expenses, time taken to travel, and etc. etc. For example, Ken takes 30 minutes to shower, Bill takes 15 minutes to shower, and Isaac takes 15 minutes to shower. Total showering time is 60 minutes. They have to reach school at 7:30 a.m. and there is only one shower room at home. We can use this method to plan for the day. What time does the first person to shower have to wake up? 7:30 a.m. minus 60 minutes equals 6:30 a.m. So the first person to shower has to wake up and shower at 6:30 a.m. So we know that that person has to wake up at 6:30, so we won't be late for school. Finding out what linear and the next one is linear and nonlinear in x. Finding out what linear and nonlinear in x is not too complicated, but explaining it is very complicated. Linear means that a line has to be straight. A linear expression has a variable that is raised to the power of 0 or 1. Nonlinear is the exact opposite of the linear equation. Nonlinear equations have variables that are raised to the power of something that is not 0 or 1. Changes in one variable can give multiple or different results. For example, x minus 3 to the power of 2 is linear because x is raised to the power of 0 or 1, not bigger or smaller, but just not raised to the power of 0 or 1. But x to the power of 2 minus 3 is not a linear equation because the variable x is raised to the power that is not 0 or 1. Linear equations can also be used in real life for constant rates, as I showed before. So for example, I got a game that costs $100. I keep on buying items in a game that cost $25 each, so $25 the game items plus $100, which is the total game, which equals 25x plus 100. X depending on how many games I buy. So if I buy 0 games, it costs $100. If 1, $125, and so on and so forth. And so the last one for Big Project 3 is finding equivalent expression. Finding equivalent expression is not too hard, but sometimes it is hard. We will have 2 different expressions, and there will be some variables that represent a number. So example, 3 to the power of 2 minus x. X will be 5. So like that is kind of like that. After that, we just find the answer and see if the answers are the same or equivalent or not. If the expressions are equivalent on the left and right of the equal sign, the expression will be a true equation. For example, 3x plus 4 equals x plus 8. So 3x plus 4 is one equation and x plus 8 is another. So if x was 2, then the expression will be equivalent because 3 times 2 plus 4 is 10 and 2 plus 8 is 10. So the answers are 10 for the left side and 10 for the right side. So that means both of the equations are the same. Thus, it is a true equation. We can use this for things like building calculations and the areas. For example, if we wanted to find a perimeter for a square, it is s plus s plus s plus s from a given area, but it was not given the length or width. This can be achieved by writing an equation. We knew the formula for a perimeter is s plus s plus s plus s, but if we use another equivalent expression for s, it will be as simpler as we know that it is 4 times s. Well, if area given to 16 square meters, we can determine that perimeter for s equals s times s, which is the area, equals 16. Therefore, 4s equals 16. So s equals 16 divided by 4, which equals 4. 4 plus 4 plus 4 plus 4 is the same as 4 times 4, which equals 16. So this is the final project that I'm going to be talking about. So the big project for the fourth big project, I learned another set of skills. This time it is more about exponents. I learned about exponential notation, scientific notation, and rules of the exponential notation. Okay, so sometimes in life we have to write very large numbers like 1 million or 10 times 10 times 10 times 10 times 10 times 10. I know that's unnecessary, but it's just fun to say it. That's a lot of zeros and a lot of multiplying, but there's something in math that can help us. Exponents. The exponential notation helps us write big numbers like this and make them simpler and easier to understand. There are two parts to knowing an exponential notation: the base and the exponent. Okay, so I'm going to give an example. 2 to the power of 3. 2 is the base and 3 is the exponent, okay? So for the and then I'm just going to move on now. For example, 1 million is the result of 10 times, or 10 to the power of 6. So as you can see, exponential notation makes it easier to write these kinds of numbers. We can find the exponent by counting the digits behind the digits behind the first digit. So example, 1 million, right? There are 6 zeros behind it, so 10 to the power of 6 will be 1 million. Or we can count how many times the number multiplies by itself. 10 times 10 times 10. So as you can see here, I multiplied 10 by itself 6 times, which makes it 10 to the power of 6. We can use this to calculate a lot of things, but mostly we use it in science. And one more fact, this exponent can only be used with only ones and zeros. It cannot be 230 million and like that. So, for example, a human has 10 million cells. Scientists can make it 10 to the power of 7, and if they reproduce X number of times, the exponent can help the scientists. Like if they reproduce 1 more million, and then it can help the scientists make it the scientists' jobs easier. So next, the scientific notation. The scientific notation is very similar to the exponential notation, except that it is able to handle a more complicated figure or numbers in real life. So this is more, real life. We can use 230 million like that. The scientific notation can contain digits other than ones and zeros. It can contain decimals too. These decimals can range between 1 and 10. For example, 230 million can also be expressed as 2.3 times 10 to the power of 6. Yeah, so we can do it like that. What is it? Never mind. Common users of this are scientific notation scientists. So or astronauts in calculating millions of cells or bacteria. So mostly scientists, as like the last one I told you, use this. So example, if the sun is 93 million miles away from the Earth, we can put it as 9.3 times 10 to the power of 6, I think. So the last one is the rule of the exponents. So the rule of exponents is just a set of rules that can help us using exponents correctly and efficiently. For example, 7 to the power of 4 times 7 to the power of 4 equals ... we don't know. But we can put this as 7 to the power of 4 plus 4 because it's basically the same thing. So it's a rule that we can do. There are many different rules, but I'm just gonna list a few. Examples like 7 to the power of 5 divided by 7 to the power of 5 can be 7 to the power of 5 minus 5. It's basically the opposite of the top one. So another one can be as 5 to the power of 4, bracket 5 to the power of 4, bracket to the power of 3. It can be used as 5 to the power of 4 times 3, etc., etc. We can use these rules by making our lives easier. In real life, scientists or other people can use these things to see distance between space and such, and a lot of different things, but this is just example. So for example, if the sun was 2 planets away and each planet is 10 to the power of 6 miles away, 1 million, they can make 10 to the power of 6 plus 6. And so that concludes my reflection video. So here are the websites that I use. So this is all that we learned this quarter, and we're gonna have exams coming up soon. So that's it that we're gonna learn for math for this quarter. And thank you for watching, and Bye bye.
Teacher, leave them kids alone.